Hello everyone and welcome. Very nice to be here as last year as well. I'm Patholit Stanis from BCG and we are a premier partner of AWS. And today we want to discuss about deploying large language models onto the edge. And in our case, edge can be anything from something running within a ship or within an industrial environment. So let's talk about some challenges to do that. Why would you need to install and run LLMs on a local case on the edge? So first and foremost, any facility, either being a ship, a vessel, or an industrial setup, has failures, and those failures cost money. So when those failures are there, you need experts, and those experts would like to help you to do that. They are also, in many cases, dependent on interconnectivity, which, as you can imagine, even with the advancements like satellite internet, it still is a case happening in maritime again and again where you are stranded somewhere with no internet access. And of course, we're talking about data sovereignty and a lot of compliance when we're talking about such highly regulated markets such as maritime. So Edge AI means local intelligence. What we want to do essentially is that we want to deploy that intelligence directly on the edge so local operators can have access to that knowledge that we can always feed from the cloud, but at the same time give them the opportunity to run independent of network access. That means you can have 24/7 access to that knowledge without having to rely on internet and you can always tap into that knowledge or operational manuals or any other thing that your company would like an employee to have access to 24/7. So let's see how we do that. So three major components. Number one is, as you can understand, you need an edge device. You need a GPU-powered device that will give you the ability to run those models. In our example here, we propose the NVIDIA Jetson platform. We can always work with other ones, but this is the proposed because it has great interoperability with AWS as well with other platforms. Next one, of course, is cloud infrastructure. Yes, we're talking about data on the edge, but you need to coordinate information. You need to be able to deploy new models. You need to be able to provide constant information, but also you need data collection. You need to create a centralized environment within a cloud infrastructure such as Amazon Web Services, where you're able to collect this data and then run analysis on them. And finally, third pillar is BCG ourselves. We can create agentic software that we can deploy locally on the edge on your infrastructure. We're able to do fine-tuning on models within AWS and then deploy that so you can have your model training consuming compute within AWS, but your inference can run within your local devices, costing only the cost of the hardware that you have already procured. And we're also to develop custom applications beyond the GPU, like custom dashboards or anything else that your company might require to have at a local edge setup. Let's dive a bit into the technical. How do we do that? Again, leveraging AWS services, specifically its IoT suite, and in this case, we're talking about Greengrass. As we can see in the diagram, we're able to have model training done within AWS. We can store the data in object storage like S3. Then using IoT Greengrass, we're able to do mass deployment of those applications and models on our edge devices. Our edge devices can be any compatible ARM or x86 architecture. As we said, we propose to use something like Jetson because it really works and it gives you great GPU availability. And then you can deploy custom workloads, as we said, dashboards or GPU-enabled workloads that we can develop together with the models that you might already have or with models we can develop with you. And what else? The data. IoT sensors. Right now, a ship, or especially in our case, we're talking about maritime, but it's not exclusive to that. It creates tons and tons of data per second. The chief idea here is that we collect the data and we can transmit them back into AWS from all our ships or any other edge point. So we can create a centralized data store, again, using AWS services. And the whole benefit here is that this is done again from the same service. We're using AWS IoT Core, which is part of Greengrass. So from the same device that does your local collection of data on the edge, you can have compute workloads, you can do local transformations of data. You can imagine someone running a local agent, so you can use natural language to query current data of your current state of the infrastructure, of your ship. You can ask operational questions. You can also access documentation, like retrieval augmented generation, as was discussed before. And all those things can be loaded dynamically from AWS centrally within a dashboard that gives you the ability to continuously feed information into your edge cases without the need of a local installer or integrator to visit the site or visit the ship and do any further installations other than the initial installation of the edge device. How do we do that in terms of business? So having worked before with similar companies, we think that the best approach is we first design a pilot program, a proof of concept. We sit down with the company, understand their needs, their data sources, understand their governance, again, very important as it was mentioned, on how they handle their data. And then we design a proof of concept that also includes employee training. After we do the installation, we're able to run that for about 2 to 4 months, get back feedback, understand the better of the use cases, and also do some extra model fine-tuning as needed. Finally, if the second phase succeeded, we can do a full fleet rollout. Again, it can be a maritime vessel, but also you can imagine any other industrial setup. So we can have the full automation of deploying the latest models, deploying the latest information, and always doing that through our AWS account with the AWS console. So we talked about how we do data collection. We talked about how you're able to run those workloads. I'll now like to give a pass to my very good friend, Ms. Mavrodimitraki from Amazon Web Services, that will explain what we can do with that data.
Great. Thank you, Thanasi. So hello, my name is Konstantina Mavrodimitraki. I'm a senior solutions architect in AWS. I have been working with data for more than 10 years, and I can tell you that the last few years I see a change in the way that companies view their data and their data strategy. Indeed, more and more companies are realizing the value of being data-driven because it helps them do a number of things, from gaining more insights to taking more informed decisions to uncovering new opportunities. To this endeavor, it's very, very important to have the right partner at crime, but also the right tools at hand. So in AWS, we offer a rich suite of services in order to support your data journey. These services are purpose-built, and they are meant to meet your demands around AI, analytics, of course, and machine learning. Most of those services are what we call serverless, meaning that your data, instead of spending the time maintaining all this infrastructure, all these servers, they use this time in order to give value to your organization. Let's see some of these services. Amazon S3, so we start with the storage layer. Amazon S3 is our simple object storage service. It is highly available. It has 11 nines of availability. It's highly durable, scalable as well. Due to all these reasons, many companies of different sizes prefer Amazon S3 in order to store and securely access their data for a number of different use cases, from data lakes to IoT devices data, to enterprise applications, backup and retrieval, and more. More than 1 million customers have placed their data lakes on Amazon S3, leveraging its performance, its security, and very, very cost also efficient. Then we have Glue, and Glue is our serverless integration service. This helps you get the data, prepare them, enrich them, cleanse them, of course. And it's meant to support different personas, let's say, from data analysts to data engineers. So it offers a visual interface, but also a code-based interface to support your integration journey. Then we have Amazon SageMaker, and SageMaker AI basically is a serverless machine learning service that is meant to support machine learning scientists and developers build, train, and deploy AI models at scale in the cloud of AWS. It supports the end-to-end machine learning lifecycle from data preparation to AI deployment, to model deployment. Finally, we have Amazon Quick Suite. This is the service that helps you do what we call democratize access to information. Actually, it's a pretty new service. We launched it 1 month ago, and it offers next generation of business intelligence capabilities. You can use, we will see it also in a small demo that I have prepared for you. You can use natural language in order to prepare your dashboards, ask your questions, and also, since it integrates with a big number of enterprise tools, you can also act upon the data as well. If we put everything together, we will see that once, let's say, the vessel is online, it can send the data to what we call a landing bucket, a landing S3 bucket on Amazon S3. Once the data lands, it is able, basically a workflow, a glue workflow can start either on schedule or it can be triggered to process the data. So we cleanse it, we transform it, enrich it. We also might have, if needed, we have the vessel rules in our NoSQL database, DynamoDB. Once the data is ready, we store it in a different S3 bucket. In parallel, we use the data in order to train models to support different use cases, forecasting use cases, like predicting maintenance, for example, if needed. Now, once the data is ready, inference is ready as well for our models, we can we can give access to our consumers to the data through Amazon Quick Suite. And let's see also a small demo that I have prepared for that. More or less, I have used I have created some data on marine traffic port call data, and then I have used this data in order to create a dashboard which helps checking the metrics around these operations. Now, normally, of course, I have created some filters. This helped me interact and specify, let's say, information that I want to see in my dashboard, a title, a description. Normally, what we do in a dashboard, we start with a more generic information, and then as we go down, we build the story which is more, let's say, more detailed. So here I have some KPIs, how my vessels are performing, and how far I am from the goals that I have set internally. Then some more information, for example, how close I am to my schedules. We see that, well, almost 40% of the vessels are not on time, so this is a problem. And then I'm diving deep in order to understand why this happens. So I'm checking the loading, unloading times that from the containers, from the ships per port. And then again, in more detail, like what are the main reasons that I'm not able to meet my, my demand. We see also some more detail. The dashboard is very interactive, so clicking upon different components, I'm diving into the specific details. And also on top of that, what I can do here, I can also create what we call executive summary. This, in a very, very quick way, gives me the specifics, like what are the key insights from this dashboard. And this is very, very convenient, as you can see. One more thing that I can do here is that, as we will see, we can create what we call data stories. So here I define my prompt, what kind of data story I want to share upon my data. And this, as you can see in a few minutes, this creates this data story, very comprehensive introduction. It takes me through the narrative of the data, the insights. I also have, if you see some visuals as well. Of course, you can, this is the magic of the prompt engineering, right? You can fine-tune it and you can guide it to, let's say, view the story from the business perspective that you want. Now, let's see how easy it is, using natural language, to create some visuals in the dashboard. So, more or less, you can, for example, ask it to create a line chart of of the loading times of my per port. And as you can see, it prepares for me a visual. I'm able to add it in my analysis. And then, again, using natural language, on the spot, I can also change the visual. So, for example, I want to change the granularity of my visual, go from the month level, from the daily level to the month level. And this does it for me, as you can see. Also, I want to change the title of the visual. Again, using natural language, it's pretty easy to do. So, as you can see, this is actually the way that I also created this, the dashboard that you saw earlier. Now, I have everything in place. Let's see how I can use QuickSuite in order to get more insights. So we can create what we call chat agents. So here I have created a specific marine traffic analyst agent. I have added specific instructions, exactly how, what it should do, its goal, how it should answer to the consumers. And as you can see, you can ask questions about, for example, how effective, what are the most efficient, for example, ports, and you get the answer, as you can see. We have, it's very important here that the tool gives us a step-by-step, it guides us through the analysis, the data that it used in order to reach the conclusions, some key performance. All the information is there just using natural language. It's very, very convenient for the business users, as you can see. Up until now, you would want data analysts and data engineers heavily, let's say, to answer these questions. Now, one last thing. Up until now, all these things depict the current trends and performances. What if we want to to explore future use cases, to do some data exploration regarding how things will look in the future? This is what if scenarios can help us do. And normally, what you do with a what if scenario, you start with the analysis on the data, you understand the data. As you can see, it gives us here the narrative, the steps that it followed in order to give me the answer. And then I'm ready to ask my what if scenario, right? What if I, for example, increase the volumes per container? How will that affect my loading and unloading times, the efficiency of my vessels and the ports as well? And this is where, as you can see behind the scenes, it uses the data, it builds a regression model, an AI model behind the scenes. Since we're talking about forecasting, it will do also some assumptions, but everything is depicted there, right? The thinking process, the consumptions that it did, and this is very, very important because we don't want a black box. We want a tool that shares exactly the rationale behind these decisions, and of course we can also change anything if needed. So with this, we finish our presentation. Thank you very much. And if you want, we can connect in LinkedIn as well. Thank you.